Hello Math 1093. In this video we're going to talk about sign making. Alright, so we've come to that point in the course where we're going to start talking about how to graph functions like the sine function and the cosine function and the tangent function and all of their friends. But we're going to start in this video by talking a little bit about how we graph the sine function. Now this is going to be a little bit different in terms of the approach than what you might be used to if you've seen this material before, because what I'm going to do is I'm going to try doing a little bit of the graph of the sine function. Not very much, because we're actually going to do this in class. I'm just going to give an intro here. And I'm going to do this without using any numbers whatsoever. That's going to be my goal, is to start the sine graph, or the graph of the sine function, using no numbers at all. Just using the idea of sine as a measurement process. Okay, so let's just review a little bit about the sine function. So here's a bit about the sine function. Okay, there's the name of it first of all. Okay. Like any function, the sine function has inputs and outputs. The input of the sine function is t, which is some arc length or radian measure. Now those are two different things. Arc length is not the same as angle measure. But we're going to start with the idea of arc length here. We're going to use that as our focus. Okay, and then what's the output of the sine function? Well, the output of the sine function, you may remember, is the y-coordinate reached after traveling that arc length. Reached after traveling that arc length. Starting at 1, 0. That arc length. Sorry, talking and writing is hard to do at the same time. Starting from 1, 0. There we go. Okay. Anyway, so just by way of illustration, I'm going to do a couple of points on the graph of the sine function. And that's it. And then after that, we're going to do the rest of this graph in class. Okay? So, let's start with some value of t that looks kind of like this. Okay, so let's suppose that's our t. It looks like that's about 1/2 of a unit or 1/2 of a radius length. Remember, this is the unit circle here. So 1/2 radius length would be just t equals 1/2. Okay. Now actually, the fact that this is 1/2 of a radius length, I'm not going to worry about it that much. Okay, I mean, I think that's true, but I'm actually not going to use that as part of the process of graphing this. Okay, I'm just going to use the fact that this, whatever this arc length is, that's my input. So I could take this arc length and imagine straightening it out and putting it on this axis, which is going to be my t-axis, and then this is going to be the sine of t-axis. Alright, so I'm taking that arc length of this one right here, and then straightening it out, and I'm going to transplant it over to this axis here. Okay, so let's put it right here. I hope that's about the same. And then our output of this function, that is the thing that we're going to graph on the vertical axis here, is going to be our y-coordinate. The y-coordinate is just how far this point is here from the horizontal axis. In this case, that seems to be about this much. Okay, so we're going to end up with a point somewhere around here. I'm just taking this length here, and I'm transplanting it over. Okay, now I'm actually going to have you do this graphing activity in class. You might not want to actually move all these line segments over. It's going to make the picture messy. You might want to just do things so that you end up with this point here. So I'm claiming that is a point on the graph of the sine function, because the input was an arc length, the output was the y-coordinate reached after that arc length, and I've combined those two into an ordered pair and put them in this picture. Alright, let's do one more, just as an example. Alright, let's suppose I do this arc length. Let's go all the way around here and stop somewhere around here. Okay, sorry, that should go just flush around the circle. I don't mean for it to be wiggly there. Anyway, let's call that t. Alright, now how long is that arc length? I don't know exactly, but I'm going to estimate it's about this much. I'm just going to draw it down here. I imagine about that much. Okay, now again, my estimation may be off, so you're actually going to have some physical tools to help you with that part, just to help you preserve lengths as you move them from the circle picture over to the graph. Okay, by the way, just to be clear, this is the unit circle here. And this is the graph we're creating. I don't know if I made that explicit at any time. Okay, anyway, we're going to move this arc length over, this big arc length here, which is a little bit over 3 radii, I think. Not that the numbers are important. And I'm going to move it over. So I think that's going to be about, I don't know, somewhere around this much. I'm really just eyeballing it here using my computer screen. Okay, but this time, what's my y-coordinate going to be? My y-coordinate is going to be the y-coordinate of this ending point here, and it's going to be negative by a small amount. So I'm going to take that y-coordinate and move it over here. And this point here is going to be another point, t comma sine of t. This time t is much bigger, but sine of t is negative. Okay, so what I've done here is I've drawn 2 points on the graph of the sine function. In class, I'm going to have you do this by doing a bunch of repeated measurements of this type. So if you don't feel you understand the process, go back, watch again, see if on another watch the process becomes a little bit clearer, and we'll talk about it a little bit in class, but mostly we're just going to get to work. Okay, I do have a couple more videos to supplement this, so stay tuned.